Here we go with the next 4 problems. We're getting into our trigonometry. This is the difference of trig, so we can antiderive them one piece at a time. The antiderivative of sine is the opposite of cosine. Minus 2, choose a coefficient, so it moves into our antiderivative. The antiderivative of cosine is sine, and then we need our plus c at the very end. So again, we're just doing it piece by piece because we're looking at a difference. All right. With number 6, we see cosecant, cotangent. Again, one of our basic antiderivative rules. This has a nice antiderivative of negative cosecant. So the 2 moves into the antiderivative, and then we have negative cosecant x dx. We want to be careful with our parentheses there. If we don't write the parentheses, it's going to look like 2 minus cosecant x. Oops, I don't want the x there. My bad. Plus c instead. And we don't want 2 minus cosecant x. That would be incorrect. So the best way to write this is actually to move our negative symbol out front. So we have negative 2 cosecant x plus c. With number 7, we have x squared minus 2 to the second power. This looks like it should be u substitution. However, if we make u equal to x squared minus 2, du would be 2x, and there is no 2x out front of the parentheses. So therefore, we have to work around this. We need to rewrite this antiderivative. We have to FOIL out or expand on this binomial. So this is the same thing as the antiderivative of x squared minus 2 times itself. Okay, but we still have a product, so we cannot do our antiderivatives yet. We need, in fact, to rewrite it a little bit more. We have to FOIL, so we have first x to the 4th. Outside gives us negative 2x squared, and inside doubles that, so it's negative 4x squared. And then last is plus 4, and that's all dx. Now, this is ready to be antiderived. So here we go. X to the 5th over 5 minus 4x to the 3rd over 3 plus 4x plus c. And we're done. But it cannot just turn into x squared minus 2 to the 3rd over 3 plus c. It will not work that way. That's not the same as this expression. Number 8, again, we have division going on. So like this one with multiplication, we don't have a rule for it, so we got to work around it. We can pull this fraction apart, similar to what we did with number 4, except number 4 was we're dealing with a product. Here we have a difference in the numerator. Thankfully, our difference of fractions tells us that we can, in fact, in essence, distribute that divided by x to the 4th to both parts. So we actually, I may not write that yet. We have x cubed over x to the 4th minus 5 over x to the 4th. All right, and this is the same thing, because if we think about it, we have a common denominator, so we can combine these two fractions. We would do the numerator minus the numerator, bingo, and then the denominator stays the same. So we're just pulling the fraction apart into the difference of two fractions. Now we can look at the antiderivative of the first one minus the antiderivative of the second one. And these fractions, while they're not ready to be antiderived right now, we can quickly simplify them so that we can antiderive them. X cubed, x to the 4th, you learned this in algebra class a long time ago. We subtract the exponents in essence. What we're left with is 1 over x. We're dividing out an x cubed. So we have the antiderivative of 1 over x dx from our first integral. Then our minus sign. And now we have 5 over x to the 4th, which is the same thing as 5x to the negative 4th. So let's pull that 5 out front, and then we have x to the negative 4th dx. Now we're ready to do our antiderivative. This first one is the natural log of the absolute value of x plus c. Come on. There we go. And then the second one is also minus 5, x to the negative 3 over negative 3, and that gets a plus c. We get to put our two plus c's together because technically there's two of them. But if we add something we don't know to something else we don't know, then we still have an unknown or arbitrary constant. So here we go. Natural log, absolute value of x, minus a negative 3. So we can see plus, double negative there, plus 5/3 x to the negative 3 plus c.